We now talk about qualitative judgments for implementing these mathematical models. Now you have to understand that the fundamental assumption which you make is that the stock price is a random variable taken from a fixed distribution. So the distribution has to be fixed. So from there you form the percentage return, and that percentage return you think is coming from some fixed distribution. But the distribution actually keeps changing. It is not constant. For example, it is erroneous to think that probability density function of gold price is same for the last 20 years. Now the prices, say, of gold, oil, iron, copper, all commodities are determined by laws of economics. So they are governed by demand and supply. There could be also technological innovations like genetic modification, which again impacts the supply. The problem currently in the market is this, that there are a large number of physicists who run these mathematical models, and they imagine that the probability density function of gold is fixed. It is not subject to supply and demand. So what they are thinking when they are thinking of a probability density function, they are thinking that it is just like the probability associated with an electron in a hydrogen atom. So when an electron is going around the proton in a hydrogen atom, it follows a certain path according to the uncertainty principle, and that path is distributed according to certain probability distribution. And if you carry the same mindset to, say, commodity prices, then that is not correct. The probability density function of gold, oil, or any other commodity is subject to laws of demand and supply. For example, if there is a war in Europe, you expect instability in euro, and this will impact prices of gold positively, because if there is instability in euro, then people are going to invest in gold. So say your initial probability distribution of gold prices was somewhere like this, and this was your mean. Now there is a war, then this distribution shape will change and the mean will also change. So now the new distribution could look like this, and the mean is somewhere here. So notice that there is nothing sacrosanct about the shape of the distribution. The distribution of gold prices might change. You can say the rate of return on gold prices still follows a normal distribution. So rate of return in the first case, which I'm drawing in green, was like this, and in the second case it just shifts like this. That is a different story. This is rate of return, but the probability distribution of gold prices might change. So what was improbable before, so in the green graph this portion was highly unlikely. Now that portion becomes highly likely in this graph. See, whatever is red here is just around the mean now. So that is, this red becomes the norm. So what was unbelievable before price is now believable, that is around the mean, because the probability distribution function itself has shifted. So again, the probability distribution function of gold has now changed. Similarly, if there is a new gold mine which is found and it has a lot of gold in it, this will increase supply of gold. Again, the probability distribution has changed. So in both cases, the mean, the standard deviation, or even the fundamental shape of distribution has changed. So then the question arises, what data you should take for running your t-test and your f-test and so on. So in any case you should do not take data of last 20 years. Certainly the technology has changed, and that has impacted almost all businesses in the last 20 years. So it is my personal opinion that you should stick to last 1 month to 6 months of data. So just focus on last 1 to 6 months of data, and the data before that is in some sense irrelevant, because the market has already taken into account the changes in demand and supply. So let us see quantitatively how to know whether these two distributions have shifted. Now this you can do easily now that you know t-test. So you can run a t-test. So say you have a commodity X and you have the rate of return for 1 to 15 days. So for first 15 days of the month or 10 working days, you have the data. And then you will have the data from 15 to end of the month. So you have two data series. So 10 days here, and then you have 10 days here. So you run data series 10 days versus 10 days. So you run t-test. You run on two data series, x1 and x2. x1 is first half of the month, x2 is second half of the month. Again, x1 and x2 are not prices, they are returns. So every 10 days you do it, and you check. If you run this t-test, you will get a confidence interval. If this confidence interval contains 0, then you are sure that not much has changed. But if this confidence interval does not contain 0, that means quantitatively the direction has changed. So you can see if there is a fundamental difference between stock returns in these 10 days. And this will indicate quantitatively what the direction of the market is for a particular stock. And this again you should be running on all your stocks and commodities in your portfolio to see the political information you get, the information in interest rate you get, how they impact the commodity prices. So before I end, I want to make a few remarks about the subprime mortgage crisis. So say before the bank started issuing subprime mortgages, see, the mortgage industry had distribution something like this. Very few people defaulted. So say these are default rates. So the default rates were very little. So default rates were say less than 5%. So somewhere here, that was the probability of default was very, very small. Now what happened is that if you change the fundamental form on which people get the credit, then you have fundamentally changed the distribution itself. So this distribution function, once the bank started giving subprime mortgages, this changed. So the mean shifted because banks are checking less and less paper. So say now this has become like this. So the mean has shifted here. So what was 5% before has now become 20%. So what was a black swan or an improbable event before has become high probability event now. Not because something spectacular or different has happened, or the mathematical model has failed, or your t-test has failed, or your f-test has failed. Nothing has failed. It is just that the fundamental probability distribution has changed. So you cannot just close your mind and hide behind the numbers. You have to understand that these numbers come from probability distributions, which are not the probability distribution of an electron moving around a proton in a hydrogen atom, which is always fixed. It actually depends upon laws of economics and laws of politics as well. So if the interest rates change or a president makes a policy statement, it is going to impact the probability distribution function of various commodities. And you have to take that into account. The probability distribution function has changed. And that is a fundamental flaw which I have observed in application of these models by a large number of physicists, is that they do not think through laws of demand and supply. They almost always end up thinking that these probability density functions are fixed, and then they give chances to people to say that your mathematical model is wrong, your statistical test is wrong, or your f-test is wrong. Whereas the truth is that the tests are not wrong. The tests, the mathematical tests and mathematical models are all correct, but they have been applied on wrong assumptions.